A perimeter is a path that surrounds a two-dimensional shape. The word comes from the Greek peri and meter. The term may be used either for the path or its length. It can be thought of as the length of the outline of a shape. The perimeter of a circle or ellipse is called its circumference. Calculating the perimeter has considerable practical applications. The perimeter can be used to calculate the length of fence required to surround a yard or garden. The perimeter of a wheel describes how far it will roll in one revolution. Similarly, the amount of string wound around a spool is related to the spool's perimeter. Perception of perimeter. The perimeter and the area of the main two measures of geometric figures. Confusing them is frequent, as well as believing that the greater one of them is, the greater is the other. Indeed, an enlargement of a shape makes its area grow as well as its perimeter. For example, if a field is drawn on a 1/10,000th scale map, the actual field perimeter can be calculated multiplying the drawing perimeter by 10,000. The real area is 10,002 times the area of the shape on the map. Nevertheless, there is no relation between the area and the perimeter of an ordinary shape. For example, the perimeter of a rectangle of width 0.001 and length 1000 is slightly above 2000, while the perimeter of a rectangle of width 0.5 and length 2 is 5. Both areas equal to 1. Proclus reported that Greek peasants fairly parted fields relying on the perimeters, but a field's production is proportional to its area, not to its perimeter. Many naive peasants may have got fields with long perimeters but low areas. If one removes a piece from a figure, its area decreases but its perimeter may not. In the case of very irregular shapes, some people may confuse perimeter with convex hull. The convex hull of a figure may be visualized as the shape formed by a rubber band stretched around it. On the animated picture on the left, all the figures have the same convex hull, the big first hexagon. Isoperimetry. The isoperimetric problem is to determine a figure with the largest area amongst those having a given perimeter. The solution is intuitive. It is the circle. In particular, that is why drops of fat on a broth surface are circular. This problem may seem simple, but its mathematical proof needs sophisticated theorems. The isoperimetric problem is sometimes simplified to find the quadrilateral, or the triangle or another particular figure, with the largest area amongst those having a given perimeter. The solution to the quadrilateral isoperimetric problem is the square, and the solution to the triangle problem is the equilateral triangle. In general, the polygon with n sides having the largest area and a given perimeter is the regular polygon, which is closer to being a circle than is an irregular polygon.